Okay, this is 9.1. I am Miss Oliva, and this is about solving systems of linear equations using matrices. So we've already done substitution and elimination, and now this is another method for solving systems of equations. This is most widely used when you have more than two variables, because with only an x and a y, it's pretty easy to use substitution or elimination. So here's how it goes. You want to line them up so that the x, y's, and z's are all lined up on one side, and then the constants are on the other side. When you do that, you can then extract the, oh, I meant to change it because it's not variables. It's the coefficients that you extract from each term in the equation to form the matrix. So when I'm looking at this one, I take the coefficients, 3, 5, -10, and then you put the 6 on the other side. So for the next one, it's 8. Since there is no y, you need to put a 0 there. 5 and 4, so there's no x. 7, -9, 10. So that's how you set up the matrix. Okay? So for the next one, it's doing the opposite. It's giving you the matrix and asking you to set up the linear equations. So that would mean 1x plus 8y minus 5z equals -3. 0x, so you don't even need to write that. So 1y plus 4z equals 14. And there's no x's, no y's, so z equals 7. And so in this case, you could see how you could solve this. Because if we now know z, we could plug that in here and we could figure out y. Once we know z and y, we can plug both of those in here and find the x. But right now, they just wanted us to write the equations. Okay, when it's asking you to do a row operation, it just means you're going to do something to one of the rows. Either you'll multiply by something, or you'll divide by something, or you'll add two of them together, whatever. So in this case, it's saying take row 1 and multiply it by -4, and then write that answer in row 1. So they didn't say anything about row 2, so row 2 is going to stay exactly the same. But row 1, I'm going to multiply each of these by -4. So that would become -8, -4, -12. And that's all they wanted. For the next one, the row operation is this, which means just switch where R1 and R3 are. So R3 comes up to row 1, and row 1 goes down to row 3. And they didn't say anything about row 2. So again, it just stays the same. Okay. Now they're asking us to solve this one. And we could solve this with substitution or elimination, but they want us to use the matrices and use this method called the Gauss-Jordan elimination. So this is a special method where you're going to take however many matrices you have, and you're going to do whatever you need to do to make this a 1, this a 0, and in this case, hopefully this a 1, but it actually doesn't have to be a 1. But this is the important part. So just a second. Okay, so first we need to write this as a matrices. So 2, 7, -15, 1, 4, and -8. And so now I just need to decide what could I do to make this a 1 and this a 0. So I could make this a 1 if I just subtracted row 1 minus row 2, right? So that's what I'm going to do for all of those, and I'm going to replace row 1 with that answer. So 2 minus 1 is 1. 7 minus 4 is 3. -15 minus -8, be careful there. That's -7. This one is still the same for now. Okay, so now what would I have to do to get a 0 here? Well, I could do the opposite. I could do, so I'm going to leave row 1 as it is, but I'm going to replace this with whatever I get when I do row 2 minus the new row 1. So 2 minus 1 would give me 0. 4 minus 3, -8 minus -7. Okay. Once you've done that, you should be able to solve this, because if you think about what this really means down here, this means 1y equals -1. So I have the y. And this means 1x plus 3y equals -7, but we now know that y is -1. So this is really x minus 3 equals -7. Add the 3, x equals -4. If they ask you to write this as a solution, you would just write it as the point -4 comma -1. So the key is kind of like a puzzle, doing whatever you need to do to change this to a 1 and this to a 0. Now, when it becomes larger than just 2 rows, it gets a little more complicated. So let's continue. Okay, so now we have 3 rows. So first, let's rewrite this with just the coefficients. Whoops, which that should not be there. Okay, so remember, we definitely want a 1 there. So when there's 3 rows, we want a 1 here, a 1 here, a 0 here, a 0 here, a 0 here, and a 0 here. And if we have 1 here, that's great, but we don't have to have a 1 there. But this is definitely what we want. Actually, I don't think this one has to be a 0. So this is what we're really focusing on. 1s here and 0s here. These can be anything. I'll just make them boxes. All of those can be anything. So another thing you can do instead of doing a bunch of adding, subtracting, and multiplying is you could just switch rows if something is there that you like. So I'm going to go ahead and switch row 1 and row 2 to get that 1 where I want it to be. So now I need to think, what else can I do to get this to be a 0 and this to be a 1 and this to be a 0 and a 0. So there's a couple options. So again, it's like a puzzle. We're going to try to think about what is the easiest way to do it. So I think I will do, where am I? I will multiply the bottom by 3 and add them together. Because you see that would be a positive 3. And when I add it together, I will get the 0 that I want. So that means I'm going to leave the top row again. And I'm going to leave the bottom row. But to get a new second row, I'm going to take 3 times the old R3 plus R2 and put it here. So 3 times 1 plus -3 is 0. 3 times -2 is -6. Plus this is -14. 3 times 2 is 6. Plus 7 is 13. 3 times -12 is -36 plus -88 is going to be a large number. Okay, so we're here. So we have our 1 in the first row that we wanted. We have a 0 in the second row that we wanted. So now we have a couple options. We could focus on getting this to be a 0 and this to be a 0, or maybe this to be a 1 next. I'm going to make this a 0 next by just subtracting row 1. So I'm gonna leave row 1, leave row 2, and do R3 minus R1. So 1 minus 1 is 0. -2 minus 3 is -5. 2 minus 5 is -3. And -12 minus -12 minus 17 is -29. Okay. So now I'm going to multiply R3 by 3, or -3, because that would give me 15 here. And so if I then added these two, I'd get the 1 that I want. So I'm focusing on making this a 1 right now. So you can see how tedious this gets when you have a large matrices. So I'm going to keep row 1 the same. And following this is going to be a little tricky. So you might want to just start trying it and then see if you mess up, kind of see what I did, and it might make more sense once you've tried it yourself. So maybe pause and see if you can even do what I'm saying before I do. So what I'm saying I'm going to do now is multiply this one by a -3 and add it to row 2 to get my new row 2. So maybe you should try that and see if you get the same numbers I get. So I'm going to keep the third row the same for now, because I'm focusing right now on fixing row 2. I like the 0, but I want to make this a 1. So I'm going to multiply R3 by -3 and add it to R2. So we would get 0 plus 0, or 0, yeah. 0 plus 0 would still be 0. This would become +15 plus -14 is 1. And that's the whole point of what I'm trying to do. This would become 9. 9 plus 13 is 22. And then this times -3, and you can be using a calculator. I'm using a calculator right now. So that becomes 87. 87 plus a -124. Excuse me, is -37. Okay. So I am almost good, right? Remember, this is our goal. We want a 1 here in the first row, done. So that's good. We want a 0 and a 1, that's good. And we want a 0 and a 0. So the only thing left we want to do is make this a 0. So how can we do that? If we multiply this by 3, and maybe the first row or the second row by 5, that would do it. I don't even need to multiply this by 3. Do you see that? If I multiply this one by 5 and add them, I'd have a 5 and a -5. So that would do it. So I'm going to do 5 times R2 plus R3. And that should do what I want for the third row. So first row is good, keep it the same. Second row is good, keep it the same. But we were trying to figure out how to get a 0 here. And so I could have done something with the first row, but you see that would have messed up my 0, because if I had to add anything to 0, I wouldn't have my 0 here anymore. So it would be better to use these two together, because then nothing would affect the zeros. So multiplying that second one by 5 and adding, I still have a 0 here. I have 5 plus -5, which is 0, which was the whole point. So that worked good. 22 times 5 plus -3 is 107. -37 times 5 plus -29 is -214. So you do not have to do what I'm doing by labeling everything. It just helps me because if I forget kind of midway what I was doing, it's right there. So how am I getting these new numbers? Oh yeah, I'm multiplying row 3, so it's always from the matrix before, this one by -3 and adding it. So that way I just don't forget what I'm doing. But you don't have to do that if you're good at keeping things straight. Okay, we should be to the point where we can solve this. Because if you have 2 zeros here, that means you should be able to figure out Z. If you have a 0 there, you'll be able to plug that in and figure out Y, and then finally figure out them all. So right now, the first line really says this. The second line really means this. And the last line really means this. So do you see why I was saying we don't have to have a 1 in that third place? As long as these two are zeros, we should now be able to solve. So I'm going to solve for Z first by dividing by 107. And so Z is -2. Now I'm going to go to the next one and say Y plus 22Z, which we just found, equals -37. So that is really a -44. So I'm going to add 44 to the other side, and I get Y is 7. And finally, I'm going to go up to the top. We don't know X. 3Y plus 5Z. We know both of those, so I'm going to plug them in. Y is 7. Z is -2. X plus 21 plus -10 equals 17. X plus 11 equals 17. Subtract the 11, and we get 6. If they want you to write it all together, go in order, X, Y, Z. Sorry about that. There you go. So if you missed any of that, this was me setting up the matrices into equations again. Since that last one would be the one I could solve first, I did that first, got -2, plugged in -2 to the second one, and got Y equals 7. Now that I have Y and Z, I went back to the very first equation, plugged in Y and Z so I could solve for X, and here is the final answer. So maybe pause now and maybe go back and maybe try that again to see if it's starting to make more sense how I'm choosing what I'm choosing to do. And sometimes there's other ways to do it. And as long as you're getting the 1, the 0, 1, and the 0, 0 somehow, then you should be able to solve it and get the same answers. Okay, last question, the word problem again. So set up a system of linear equations to represent the scenario. Solve with Gaussian elimination or Gauss-Jordan elimination, which means using those 1s and 0s like we just did. All right, Jamila stayed in 3 different cities: Washington, D.C., Atlanta, Georgia, and Dallas, Texas, for a total of 15 nights. So I'm just going to start right now and say that X is nights in D.C. Y would be how many nights in Atlanta. And again, if you can keep this straight, you don't need to list it, but I like to list things so I don't forget halfway through what each one means. So Z is going to be the number of nights in Dallas for a total of 15 nights. Okay, I can set up one equation right now. If I have no clue how many nights I spent in DC, Atlanta, and Dallas, but I know that they add up to 15, that is one of your equations. Right? Whatever X, Y, and Z are, they need to add up to 15. Now, it also says twice as many nights were spent in Dallas as Washington, D.C. Twice as many nights were spent in Dallas as Washington, D.C. A lot of people are going to mess up this equation and be like, all right, twice Dallas equals DC. But that doesn't make sense because if Dallas already had twice as many as DC, this is the larger number. So if we're taking that larger number and multiplying it by 2, how is that possibly going to equal the one that was less than it anyway? So if it says twice something equals something else, it's actually the something else you need to multiply by 2. So Z as it is equal to twice the number of nights in DC. So maybe read that, think about it again, but a lot of people mess this up and I understand why. But if you think about it, doing it the other way doesn't make sense. And then finally, the cost of staying in all those places for all those different nights, the total of it is 2,670. Determine the nights spent in each city. So here's where we need the chart, because I can't just say x plus y plus z equals 2,670, because x, y, and z are just the number of nights. So where am I getting this price from? But if we now know that each night in DC costs this much, Atlanta costs that much, and Dallas costs that much, now we can set it up. That's 240 times however many nights in DC, plus 90 times the nights there, plus 180 times the night there. And there we are. So they want us to do this with the ones and the zeros, but you don't really have to. I can't help but look at this and think I would immediately just start substituting. Because it says right here that z is the same thing as 2x. So I'm going to go and replace the z's with 2x. So when I do that, the top line becomes x plus y plus 2x equals 15. So you see I'll be able to put those x's together. And the last line becomes 240x plus 90y plus 180 times 2x equals 2,670. So let me just simplify these and make them a little nicer. 3x plus y equals 15 is one equation. And 240 plus the 180 times 2 is 600. Okay, and at this point, I would now choose elimination. Because if I have a 90 here, I can easily get a negative 90 up top. So I'm going to multiply the whole top by negative 90. If you like the new matrix methods, you can go ahead and do that here. But if you're doing this at home, this one is one where I wouldn't blame you for using another method. So top line becomes negative 270x minus 90y equals negative 1350. The next line can stay as is, because now we have opposite numbers there. And so now we're going to add. We get 330x, the y's are gone, equals 1320. So all we have to do is divide by 330 and it works out nicely. There's my x. So I can immediately find the z, right? Because z is twice x. So that just means z is 8. And now we can go back all the way back up to the very beginning to easily find the y. So x is 4. We don't know y. Z is 8. And it should all add up to 15. So that means y must be 3. Final answer, 4, 3, 8. And that is it for 9.1. Let me know if you have any questions as you work through the homework.